Okay, using the Hazen-Williams equation with a C factor of 125, that is 125. Calculate the frictional pressure drop per miles in the 20-inch pipeline described in problem 3.15.1 above. Repeat the calculation using the Shell, MIT, and Miller equation. Oh, this is Hazen-Williams equation, where the flow rate is equal to 0.1482 times the C factor times internal diameter raised to power 2.63 times the pressure drop per miles divided by the specific gravity raised to power 0.54. So we are asked to calculate the frictional pressure drop per miles, which is this. Now let's write the given parameters. We are given flow rates. Let's see from the first equation, from the first problem. Here, the flow rate is 250,000 barrel per day. So we have 250,000 barrel per day. Now the internal diameter is we calculated the internal diameter. Okay. We calculated the internal diameter to be 19.25 inches. Calculated it to be 19.25 inches. And then the specific gravity is what? .85. The specific gravity is 0.85. Now let's make Pm the subject of formula. So now to do that, we just say Pm all over Sg, that is specific gravity, all over specific gravity raised to power 5/4. It's the same thing as saying Q divided by 0.1482 C times T raised to power 2.625 263. Now the Pm will now be equal to this 0.1482 times C times T raised to power 2.63 or raised to power 1 all over 0.54 times specific gravity. Now we have gotten, since the Q from this formula, the Q is in barrel per day, the C is in inches, so we will just insert all the values without considering we will start the values without considering the units, since they are of the same unit, so I don't need to touch the units. So what I will do now is I will say the flow rate is 250 divided by 0.1482 times the C is 125 times the D is 19.25 or raised to power 2.63 raised to power 1 all over 0.54 times the specific gravity, which is 0.85. So now let's use our calculator. From my calculator now, I have 250,000 divided by 0.1482 divided by 125 divided by 19.25 raised to power 2.63. So this is what we get. Then now let me see the second function. This y root of 0.54 so this is what we get now, times 0.85. So answer now will be 21.21. Okay, that's 21 psi per mile. This is the answer for using Hazen-Williams equation. Now using Shell-MIT equation. The Shell-MIT equation is, now we have calculated the Reynolds number, and our Reynolds number from the first equation was what? We have 203114. Okay, let me just write up here. Let's say using shell MIT equation. Now this is 203114. Let me confirm again. Let me confirm if it's what we get. Okay, we have 203114. So now needed to calculate the modified Reynold number. So the modified Reynold number will be 203114 divided by 7742. Now this should be let me see, let me calculate it. Now we have 203114 divided by 7742. So we have 26 point. Let me just write it down. We say 26.23235. So this is the modified Reynold number. Already this is a turbulence flow. The turbulence flow. So I will use the friction factor for turbulence flow. So the friction factor for turbulence flow should now be 0.0018 plus 0.00662 1 all over Rm raised to power 0.355. Now, so let me just check if this is correct. Let me look at the equation here. So okay, here is 70, here is 72. Let me look at where that formula is 72. Here is 82. The page number is 82. Let me go. So where the friction factor is, let me see. For turbulence flow. So okay, this is okay, it's correct. So for turbulent flow, so it's not laminar flow since the Reynold number is more than 4,000. Now let's go back to this. So it's correct. Now we'll now say 0.0018 plus 0.00662 times 1 all over 26.235 raised to plus 0.355. Now let me go back to my calculator. Now we have gotten this, which is this. So I'll take the inverse of that. Then raised to power 0.355. Then I'll multiply it with this, which is 0.00662. Then plus 6 plus 0.0018. Oh, friction factor will go 0.00387. 0.00387 is 3, okay, 0.00388 is a friction factor. Now when I use this formula now to get our when I use the Shell MIT formula now to get our pressure drop per mass. So this PM will be 0.241 bracket open times the friction factor times the specific gravity times the flow rate square divided by d raised to power 5. Now I've gotten this. Now what we do now is we now go to, so this is it now. We use this, we multiply it with our acceleration due to gravity, which is 0.85. Then multiply this with this, which is 0.241, then times this. The flow rate is that's flow rate squared to 250,000 raised to power 2. Then divide by the D is 19.25 raised to power 5. We divide by that, so we got 18.77 per miles. So this other one is 21, this one is 18. So let's do the other one.
You said that I should go and give him.
Now let's do for Miller equation. Now the Miller equation is Miller equation. Now for Miller equation we needed to have this equal to 4.06 m brackets d raised to power 5 pm raised to power 0.5. Now and we also have now where m is equal to log 10 d raised to power 3, which is d is internal diameter, d raised to power 3 times specific gravity times pressure drop per mass divided by centipulse raised to power 2 bracket close. Then plus 0 plus this is 4.35. So the flow rate which is Q is in gallon per. Okay, let's now the flow rate here is in gallon, is in barrel per day. The flow rate, the unit is in barrel per day. The diameter, the internal diameter is in inches. The PM is in psi per mile. Then CP is centipulse. Now it's similar to this. This one is also barrel per day. The D is in inches. I've also explained that this one is also the flow rate. The flow rate. So where the flow rate here is also in barrel per day. The internal diameter is in inches. The PM is in psi per miles. So that is this. That's equation. So now using this now, first we'll look for the M. The M is not given. Okay, let me just write the given values. The given values, they gave us Q, which is 250,000 barrel per day. Then they gave us the specific gravity, which is 0.85. They gave us internal diameter, which is now 19.25 inches. Now the centipulse, they didn't give us centipulse, so but the specific gravity times the kinetic viscosity will give us this, so which is 0.85 times the specific gravity in centipulse is what it will give us 5.9 centipulse. So this is 5.9 centistole. So this will now be 0.85 times 5.9. It will give us 5.015 centipulse. So now we don't know the M. First of all, we look for M. So M is equal to log 10 log base 10 d raised to power 3 times specific gravity times PM divided by CP square all plus 4.35. Now we need to get our M. Now for you to get your M, we need to assume the value of P. We need to assume the value of PM. let's say it's 10.0 per mile. Now, for us to get our m, so there is going to be an iteration. So if we assume pm to be equal to 10.0 psi per mile. Now we're going to, because that is the only thing that is not given in this m equation, in this Miller equation, this value. Now we know this, we know this, we know Cp, we don't know this, so that is the only unknown there. Now to get, so now we'll now get our assumed m, because this is not the right, this pm is not the right, p subscript m is not the right value. So we're getting an a kind of force n. So let me say this log 10, this is 19.25 raised to power 3 times 0.85 times 10 divided by 5.015 square for 0. Now we now have, so let's calculate this. Let's see, let's use our calculator to do this. We'll have, now okay, what we'll do is square this value, square it, take the inverse of it, multiply 19.25 raised to power 3 times 10 times 0.85. This is equal to, now we'll not look for the log of this. So the log of it is 3. The log of that is 3 points. 3.3822. 3.3822 plus 4.3235. What will it get us? This is plus 4.35. So this will be 7. This will give us 7.7322. Now we've gotten our m. Now we need to rearrange this to make m the subject of formula, to make p subscript m to the subject of formula. So we have q equal to 4.06 m, 4.06 m bracket d raised to power 5 pm divided by sg all raised to power 0.5. Now to make this the subject of formula, we'll now say pm will now be equal to q all over 4.06 m all raised to power 1 all over 0.5 this is same thing as 2 times specific gravity divided by d raised to the power 5. Now let's calculate our. This is same thing as this one is same thing as 2. Let me just write it as 2 because so we'll say Q divided by 4.06 times M raised to power 2 times SG divided by D raised to power 5. Now we'll not do the calculation now. We'll have this at 0.0, that is 25,000, 4.06 times M, which is 7.7322 raised to power 2, because 1 divided by 0.5 is 2. So then times this specific gravity 0.85 divided by internal diameter, which is 9.25 raised to power 5. Now let's get the value of PM, which is not the correct one, which is still not the correct, because we'll compare it with this assumed value here. If it's not the same, then we'll continue with the integration. Now let's use our calculator now. Let me copy this because I will be using it subsequently. Let me copy it. Now this, I will use the inverse of it. Then I will multiply 25,000 to it. Then I will divide this 4.06 on it. What I got, I square it. Multiply 0.85 with it. Then divide 19.25 raised to power 5. So I have 20. I have 20.39. So I have 20.39. So what we'll have is 20.39 psi per mass. So this is not the correct answer, because the assumed value, which is 10.0, is not the same with this. So what we'll do, now use this one to calculate our M again. So we'll now put this value inside this one to calculate our M. So our M will now is equal to log 10. Now making this one the assumed value now. Making this the assumed value. We'll now say M is equal to log 10, log base 10, d raised to power 3 times specific gravity times PM divided by CP square. All bracket plus 4.35. Now we'll now say this is log 10, this is 19.25 raised to power 3 times 0.85 times this assumed value now, which is the new assumed value, which is 20.39 divided by the CP, which is 5.015 square plus 4.35. Let me be sure that is the CP. The CP is okay, correct. Now let's get our new M now. Let's go back to our calculator. We now have 19.25 raised to power 3 times 0.85 times 20.39 divided by 5.015 square equal to this. Then the log of it is this plus 4.35. So this is what we get. This is our new value. So now we'll copy it. Copy this new value. I can leave it there. Okay, but let me just write it down. I have 8.0416. 8.0416. That is what we got. This is our new value of M. Now we'll use this new value of M to get our PM again to see what it will look like. So this is it now. So our PM is equal to P subscript M is equal to Q all over 4.06 times M all raised to power 2 times G all over D raised to power 5. Let me see. It's correct. Okay, it's correct. It's correct. So let's work it out again. I have my flow rate to be this divided by 4.06 times my M is 8.041416 all raised to power 2 times 0.85 divided by 19.25 raised to power 5. So look at what our piece of screen M will be. So now we'll have our M to be this. Take the inverse of it. Multiply 250,000 to it. Divide 4.06 to it. Then square. Multiply 0.85 to it. And divide by 19.25 raised to power 5 equal to 18. So we have 18.85. We say 18.854 psi per miles. Now this is what we get. Now you see it's converging a little. It's converging because this is 20, this is 18 now. It's coming closer. So now, but it's not the same. There's still great difference. So I will do it till I get to a point where I will have the difference should be 0.5 0.5. Sorry, 0.1. Now if you subtract this from this, let's see it. This value, let me just copy this value. Copy. Then now let me just say this is negative plus 20.39. So I have 1.5. So the difference is very high. So until the difference is 0.1 psi per mile, then if it's until it is less than or equal to 0.1, then I will stop. So now let's now use this to calculate our m. So now we'll come to this place. Now we insert it here. So let's use our calculator now. Let me bring on this. I have 19.25 raised to power 3 times 0.85 times I will now paste this one. That one we got. So I'll paste this because it's not this again. Then I will divide by 5.015 square. Now I will now do log of that plus 4.35. So we have 8.0076. So assuming PM is equal to 18.854, M now becomes 8.000. Let me see, 0.076. Now if I use it to get let's use it to find our PM now. So our PM, inserting it into this position. So let's say let's use this equation again. 0.6 times M square times SG divided by D raised to power 5. So this is 25,000 divided by 4.06 times 8.0076 all squared times specific gravity, which is 0.85 divided by 19.25 raised to power 5. Now let's look what is our PM. Yes, per miles. Let's look at what is our PM. Now we'll take the inverse of this, multiply with 25,000, then 250,000, divide by 4.06. Then square times 0.85 divided by 19.25 raised to power 5. We have 19. 18.01 015 x miles. So if you subtract this from this, let's see the difference. This minus 18.854. Is it 854? Let me see. 854, correct. Let me see. Go to this. So I have 0.16. 0.16. So I can stop here. This is accurate now. I can stop here because it's 0.1. It's okay. Let me continue. This is roughly 0.2. Let me continue. If I get to 0.1 psi per mile, so I will just stop. We have this now. Let's calculate our PM. Let's calculate our M. This is log 10 d raised to power 3 times SG times PM divided by CP square, all in bracket. This is 4.35. Now we are using this now as the assumed value. We want to calculate our M. So we have log this 10, we have 19.25 square cube, times 0.85 times 19.015 divided by 5.015 square plus 4.35. Now what is the M now? Now our M should now be, we have let me add 18.854. now I have this, multiply 0.85 to it, multiply 19.25 raised to power 3 to it, divide by 5.015 square. The log of it was 4.35. So we have 8.011. Let me see. 1126. This is the value of our M now. Now we use it to get our PM. You see, our PM will now be Q all over 4.06 times M. This by 2 times the specific gravity divided by 5 the internal diameter raised to power 5, which is 250,000 divided by 4.06 times M, which is 8.01126 raised to power 2 times 0.85 divided by 19.25 raised to power 5. Now we now have our P subscript M. Now let's just say this, inverse of this times 25,000 divided by 4.06 square times 0.85 divided by 19.25 square. No, 18 raised to power 5. Sorry, square. So you have 18. You have 18. You now have 18.997 PS. So this should be the answer now. This should be the answer. If you subtract this from that, what will you get? If we subtract this, let's say 18.997. The other one is 19.015. Yeah, 15. Now you have, let's say this plus 19.015. So this is even very, so we have 0.0177. So we are looking for 0.1 psi per mile difference. But now we have more accurate results. So this is the final result. So we end it here. But before I end it here, let me use my the program I created to solve that question. Now the first one, they say we should use example equation. So here is 125. Here is 20. Here is 0.375, which is, this is this is 25,000. This is 0.85. Now, from the two questions, they didn't give, let me see, they didn't give the length of pipe, so we're looking for per mile. So we're looking for per mile. So we have, okay, that means they didn't give the mileage of it. So now from that equation, I will assume the mileage is 1, because since it's per mile, so if you say 1, it's okay. Okay, we say so. So pressure drop from my own is 21.05. Let's see what we got there for Hazen Williams equation. For Williams, we have 21.0.0. So the same thing with what I got here. So it's 21. So this should be 21 because the pipe length is 1 mile. So let's look at using Shell MIT. For Shell MIT, this is 5.9. This is 25,000. This is 0.85. And this is 280. This is 0.375. This is okay. I don't think I need this. Okay, 1 mile. 1 mile is equivalent to 1 mile is equivalent to 5,280 feet. So let's assume, but this is what we're looking at. We're looking at the PSI per mile. So this is 18.77. 18.77. Let's look at it again. Let's go back. This is the let me look at it. Okay, so this is correct. We got 0.00388 here, or here we got 0.0039, so it's correct. Now we have this PM as 18.77, and here we have what? 18.77, correct. Now let's look at the Miller equation. For Miller equation, let's see what we got. Now let's see, using Miller equation. Now here is the centipose. So we need to convert that to centipose, and centipose is 5.015. If you multiply with the specific gravity, then this is 25,000. 250,000 barrel per day. So this is 0.85 specific gravity. The outside diameter is 20. The internal diameter, the pipe thickness is 0.375. Let's say the pipe length. Let's use the pipe. Let's say the pipe length is. Let me use that 5,280. Now let's calculate. You have pressure drop to be 19. You have the pressure drop to be 19. So let's look at what we got here. 19. So it's roughly 19. This is 18. This is 18.997. So it's roughly 19. It's roughly 19. So it's 19. So 19 is the answer. So that is that. Let me exit and close this. So let me stop. Thank you for watching. Have a nice day.